Remember? So this part of the chart is about the distribution of a variable in the population. So it's called probability distribution. Now this is distribution of the variable in one sample from a given population. And those two are related. Now comes a point that connects these two, and that is sampling distribution. I'm going to give one more sentence before we are up with the time. Yeah, okay. So what is that important thing about sampling distribution? Well, just imagine. I'm going to move on to the next slide. Now that you've understood some basics of this, right? Let me show you something else. This particular thing called sampling, this is sample distribution. This is probability distribution. And the thing that we're going to talk about is it's called the sampling distribution. Sampling distribution. Now, what is sampling distribution? Let's actually magnify this. Well, the idea is simple. Let's take a sample. You've taken one random sample, right? And you've calculated, let's say you're interested in quantitative variable and you're summarizing that quantitative variable. Let's say height of college students in the US. So you've randomly selected, say, 100 college students, and then you calculate the average height. And that average height then would be X bar, right? That would be equal to X bar, and that X bar, let's say, is 6.5. So this is just one sample. What happens if you take another sample? Would it be 6.7 again average? Of the same sample size of 100 students, it will change. Let's take another sample of 100 and do it again. Would it be same as 6.5? It will change. Each time you collect a sample of the same size, the value changes. The standard deviation of that individual sample will also change. So let's assume the first time we took a sample size of n, the value of it x bar a. Second time you did it, it's x bar b. Third time did it, x bar c. Fourth time you did it, x bar d. Remember, what are these x bars? Is the average mean for that sample. Remember the sample statistic, which is different from the population statistic or population parameter. So that is the idea. Now keep in mind, there is this population mean, which has a population mean of mu. The sample you have selected is just one possible samples of thousands of millions of possible samples of a given size. And so what is sampling distribution? Sampling distribution is the distribution of the sample means. Sampling distribution of means is the sample distribution of all sample means. If you take sample means, if you take samples of size n and calculate the mean each time and you plot it, right? Then the average of all those means, sample means, would be equal or close to the actual population mean, which is mu. Does it make sense? Okay. So this is like a probability distribution. These are like individual samples. If you plot all the individual sample in another distribution, you call this sampling distribution. The the average of that sampling distribution would be equal to the population mu, but because the individual values are x bars, this particular average of sample means is called mu x bar. Again, we'll talk about why it is so, how it changes, and other things when we meet.